Hi everyone, the question is, let p of x be a polynomial with real coefficients such that p of sin square x is equal to p of cos square x for all x in this interval 0 close to pi by 2 closed. Consider the following statements. P of x is an even function. P of x can be expressed as a polynomial in 2x minus 1 whole square. P of x is a polynomial of even degree. Then we have to comment upon which of these three statements are true and which are false. So here if you see carefully, you have p of sin square x is equal to p of 1 minus sin square x. So here what you have essentially is, if you replace sin square x by t, let's say p of t is equal to p of 1 minus t for every t belonging to this interval 0 close to 1 closed. As x varies from 0 close to pi by 2 closed, sin square x varies from 0 close to 1 closed. So here you may replace, since this holds for all t in this interval 0 close to 1 closed, and you may say essentially if it is a polynomial and if it is defined, for example, in case we extend the definition to all real numbers as such. So this polynomial, whatever comment we make in this case for t belonging to 0 close to 1 closed, it can be made if polynomial would have been defined in general for all real values of x or real inputs. Here basically regarding polynomial we have been given information when the inputs are between 0 close to 1 closed. So here let's put t to be let's say half plus t. So what you get is p of half plus t is equal to you have p of 1 minus half plus t is what? It is half minus t. So you can clearly see that this polynomial is symmetric with respect to t equal to half. That means it is symmetric with respect to input being half, because if you go t unit right of half or t unit left of half, the functional value is the same, the polynomial value is the same. Or if I should write in terms of x only, it essentially means p of half plus x is equal to p of half minus x. So basically this polynomial is symmetric with respect to x equal to half line. Now is this an even function? Not necessary. Why? Because here the polynomial is symmetric with respect to x equal to half and not with respect to x equal to 0 necessarily. Yeah, for even function the function is symmetric with respect to x equal to 0, which is essentially the y-axis. But here it's not so. So 1 is not necessarily true. That means we should say statement 1 is false. Coming to statement 3, if you see carefully, as x tends to infinity, p of infinity is what we have on left hand side, and p of minus infinity is what we have on right hand side. Yeah, and the two are equal. If polynomial px would have been an odd degree polynomial, then the value that it would have taken as input goes to infinity as compared to what it would take as input goes to minus infinity would be opposite in sign. Yeah, if x tending to infinity gives the functional value infinity, then x tending to minus infinity would give the functional value minus infinity, or vice versa. Yeah, but here it is being the same, and this can happen only in the case of even degree polynomial. Again, polynomial can either be even degree or odd degree. It is not odd degree, and it is clearly even degree only. So third statement is true. Now coming to the second statement, if polynomial is an even polynomial, that means if the polynomial is an even function, then it is symmetric with respect to x equal to 0, and then you can that means you can express the polynomial entirely in terms of x minus 0 whole square, basically entirely in terms of x square. Yeah, and in the present case the polynomial is symmetric with respect to x equal to half, so you can express the polynomial px entirely, you can write it in terms of, or express it in terms of, x minus half whole square, which is equivalent to expressing the polynomial in terms of 2x minus 1 whole square. Now you may say divide by 4 would come. Essentially those are constant terms that would not matter much. Basically you can say you can express the polynomial in terms of 2x minus 1 whole square. So statement 2 is also true. So that means you can say only statement 2 and 3 are true. C is the answer. Thanks for listening.